Hello, and thank you for joining this month's webinar entitled Everything You Need to Know About Slab Heating. My name is Scott. I'm from WarmlyYours, and
My name is Anatoly.
he's from WarmlyYours too. And we are so glad that you're able to join us today. So if you have any questions at any time, feel free to click on the Ask a Question section down there at the bottom of your screen. And any questions that come in, we'll be glad to answer them. So I'm going to make sure that I move our little presentation over here so I can see any questions that come in. And let's go ahead and get started. So today's webinar, we're going to talk about slab heating uses, the different ways you can heat if you have a slab, slab heating systems, and the different steps you need to use to get that heat installed, whether it's on top or actually inside the slab. We're going to talk about heating the inside of the slab primarily today, but there are different ways to heat a floor when you're over slab. So we're going to mention that too. So what's the benefit of having a heated slab?
Heated slab gives you a good advantages comparing to maybe all other types of heating sources, because you heating the slab, you heating the foundation, that heat eventually transfers and radiates into your whole room, potentially whole house, depending how much heat you have installed. So the good thing I like about it, you're not losing lots of heat. That's a big part. You're kind of heating that foundation, you're creating that thermal mass.
And what's great is these, if you have a slab and it's naturally going to feel cold. So if you had heat coming from overhead ducts, let's say you were in a basement, then all that heat would be coming from above. It gets about 2/3 of the way down in the room, and then it goes right back up to the ceiling. So your feet really never get warm in a forced air situation, whereas your feet are the first thing to get warmed up with this system. So this is a lot better, especially in basements when it comes to that over HVAC systems. So we're going to talk primarily about heating the slab, but let's say that the person already has a slab in place. What we're talking about in this particular slide is that you have a slab already and you want to heat the floor above it. Later, most of this presentation will be about pouring a brand new slab and getting heat built into that slab. So let's talk about warming a room over an existing slab.
Yeah, so in case the slab is already finished and you need to, or you want to add, of course, the floor heating here, the biggest key element here is to add that thermal break, to add that insulation over your existing concrete slab, because you want to make sure your floor heating is nice and warm, and you don't want to try to heat that slab at this point because it's already finished and complete. So adding the insulating underlayment here, like it's shown on the picture, one of our products like a synthetic cork or so, creates that nice thermal break, makes your floor heating that is installed on top work nice and efficient, getting to the high temperatures and so on.
Yeah, so we're actually heating just a very thin section, less than 1 inch to 1.5 inches of material, which makes it heat faster. It probably get a little bit warmer, and it'll definitely allow you to change much quicker, as opposed to a concrete slab that you're heating is going to be a much longer heating duration.
Right.
So you're kind of like doing two different things. This is for a system that's going on top of a slab that's already existent in the house. So we've covered the top of the slab. That's what we do most of the time here at WarmlyYours, because we talk to people who are remodeling, and there's a lot of remodeling work that's done on a slab that's already there. But let's say we're building a new house, or we're putting on a new addition. So if we're going to be putting on a new addition, this is the time where we're going to actually be warming up the slab. So what we need to look for when it comes to heating slabs?
So when heating the slab, I mean, first, I think it's always good to talk and understand how the customer want to use that system. Is it something just for a quick 1-hour use? And that's maybe the case when you still want to go back to that previous system and install it on top. But when you're building a new home, you're having that new slab being poured, and let's say you want to use a polished concrete or some nice stamped concrete as a final flooring surface here, slab heating products or slab heating mats and cables that we provide would be the best product to use. We have those in cables and mats. The cables use about 5 watts per linear foot. Mats can provide up to 20 watts per square foot. So that's the perfect high wattage product, durable product that is made specifically for these applications.
Yeah, and if you're in a basement or you're doing a big house, a big concrete pour, usually you have to locate an expansion joint or two. And if you do have an expansion joint or two, you're going to need to talk to your concrete installer, and you want to make sure that you tell us where those expansion joints are, because we don't put heat under those spots. So we're just getting into talking about warming up a new slab, but I want to go back to the one before, slide number 5, because we had a question about this slide, and it was from Gary. Gary sent us in a question a little bit earlier and said, "Is there insulation between the concrete slab and the flooring?" Well, the answer to this case is yes. This is, once again, Gary, heating a slab that's already, that you're not heating the slab, but you have a slab, you moved into a house, the slab's already there, you want to heat on top of it. So there is a difference. If that's the case, you use insulation. If you want to actually heat the slab, then there would be no insulation, because you don't want to block the heat from your feet. So this is actually the concrete slab is getting charged with heat. And that's exactly what's going on here. So Gary, thank you for asking that question. So once again, expansion joints are very, very important. Let us know where they are, so we'll design the product around that. So warming up a new slab with flooring. So this is actually when you're going to install carpet or tile or something on top of that. How is that different?
Yeah, I like that slide. There's a lot of bullet points. There are a lot of information to talk about here. So yeah, there's really those two sort of subcategories here, where you just want to heat the slab, or you want to heat the slab and have the flooring on top. If you do have a flooring on top, you really want to check with your local electrical code, or see how they adapt the national electrical code, to understand what are the requirements in terms of wattage per square foot are needed here. Typically, it's 15 watts per square foot, but that was recently changed. So once again, check with your local code, see what requirements you need to follow. We will design our system, our plan, according to those requirements. And at this point, we can see if this heating cable needs to be used here, maybe spaced 5 inches apart, or it's the heating mat, the slab heating mat, that can be used at 20 watts per square foot.
Yeah, what the NEC is doing, the National Electric Code, different states are in different years of the National Electric Code. The 2017 National Electric Code doesn't have a limit on the number of watts that you can have in your floor. So that's a case where in some states you can do 15 watts with the floor covering, or in some states that have 2017 coverage, then you can put out however many watts you want to put in there. So there is no limit there as to what you can put in. So that it's pretty much that requirement is gone. You don't really need to worry about that anymore. So the thing you need to remember is the closer the cables are together, the more watts per square foot you get, the warmer it will get. The further away the cables are from one another, the fewer watts per square foot you have, and the cooler temperatures you can expect. So just always keep that in mind. So here we have slab heating systems. So let's take a look at these two types. What's going on here?
So we have cables and mats shown here. And generally speaking, I always like to explain that this is really the same product. It's the same type of heating element that produces the same amount of heat, but with one or the other product, you are can accomplish different applications. And with a cable, for example, you are so much more flexible. You can cover different areas, different shape areas if it's needed. You can come up with those different designs. So depending on the project, depending on that floor plan that we'll receive, we will design to the best of our ability to make the installation as easy as possible. And again, depending on those requirements, we'll pick one or the other product that will be used.
Yeah, so it's that blue cable that's attached to the mesh. Excuse me. The main thing about the mesh product is it's much faster to install than cables. So that's just something to keep in mind too. If you can do 20 watts per square foot, then use mats. They're so much faster to put down than the loose cables are. So that's one thing that you don't want to be having a concrete truck there ready to pour concrete, and you're still tying these individual cables down to the rebar. That's really, really a bad scene, and those guys get really upset, and they charge you lots and lots of money for that. So we had a question from George about what is the minimum recommended concrete thickness and concrete cover. So most building codes are going to say you have to have at least a 4-inch slab. Some say 6 inches okay, or whatever you want to do, but concrete's really expensive. So you don't want to pour, 20 inches of concrete unless you're making an airport runway. So what you want to do there is, we realize that slabs are usually 4 to 6 inches deep. What you want to do is you want to get the cable propped up into the middle of this pour. So notice there's 2 to 3 inches over on top of this cable. It's pretty much the same thing with these, or it's once again the same product. But the National Electric Code says you have to have 1.5 inches of some non-combustible product in here. It would be concrete. It has to be at least 1.5 inches over the top. So that's the most important thing. I think what you might have been getting at there, George. Is there a minimum above? And yes, the National Electric Code says it has to be at least 1.5 inches over the cable before you get to the top of the flooring. So talk about the layers here and the different ways of putting this product in.
Yeah, the layers are, looking at the cross section. It's always good to have that cross section when you are maybe in that planning stage, or planning with your concrete professionals. You want to always, like Scott said, have that heating product in the middle of that pour. The last thing you want to do is have that at the very bottom and covered with 6 inches of concrete. It's going to take too much time to do something or heat, or there may not even be much heat transferred to the top surface. So
yeah, and one thing, I'm sorry to interrupt you, but I have to say this before I forget it. If your concrete installer says, we'll lay it down on the compressed crushed rock, then we'll take a rake and we'll pull up on it to get it into the middle of the pour, that's not the way to do it. And you know what happens when those rakes go in to the concrete? You know what they hit?
They're going to hit the cable.
They hit the cable. Yeah. So you have to watch out for that. If you see if the concrete installer says, hey, I'm just going to pull up on it with rakes, tell them, no, that's not going to happen. You need to install it the correct way. So that's one thing to look at here. So let's talk about the next slide. And what do we have here? What's the main difference between these two pictures?
First of all, we have heating cables and heating mats. The positioning of that product is still at the same layer, but on that picture, you should see on that more lower right-hand corner sort of the mat, there's a black part sticking out kind of out of the blue wire. That's your factory splice. That's, in other words, it's end cap factory splice. That is, in other words, a termination of the cable.
Yeah, we're gonna talk about that in the next slide.
Yeah.
But what the difference I like to point out here, there's a lot of cable ties here holding the cable to the rebar, and there are not as many here. Because what you can actually do is you can actually use the mesh to hold it down too. Excuse me. So when you are doing this type of install, the one thing you need to tell your concrete person, if you're doing an install with this mesh product, is they need to use sub 3/4 inch aggregate. And that means that the maximum size of the aggregate inside the concrete is 3/4 inch, because those little squares are 1.25 inch squares. That's why they're called squares. So the thing is, if you have 1.25 inch, all that aggregate will pass through it and allow you to pass through the mesh and allow the concrete to fill up naturally up to its appropriate height. So you don't have to worry about the mesh clogging or whatever. But you have to tell the installer we're going to be doing that, and they need to make sure sub 3/4 inch aggregate is to be used there. So let's talk about those splices.
Yeah. So the splice that is circled with a red circle here, that's that end cap. What we always want to do, since this is the part of the wire that you really want to kind of give that extra layer of
Caution.
be gentle with that. Yeah. Be gentle with that part. Put the flags when the concrete installers are working with that. Set up the flags at that spot at the end factory splice. There's the similar type connection, what we would call it a start factory splice connection. Put another flag there, just so when installers are working with that, they are really careful around those areas, and of course around the whole cable, the whole rest of the mat and the cable.
Yeah, those installers are going to be out walking over the cable. The last thing you want them to do is to walk on these splices, because that's where the actual two wires are tied together and they're mechanically spliced together. And what you need to do then is you need to make sure that you don't walk on them. We have not talked about insulation under the slab yet, because that is not a requirement everywhere, but I'm glad you brought it up, because the insulation, do we have a slide about insulation? No, we did. We might not. But anyway, some localities require it, and usually it's a 2-inch board of EPS or something like that. So always check with your building codes to find out if you need that and if you need perimeter insulation around the slab, because some will say you just need a 2-inch board and that's it. Some will say you need a 2-inch board plus perimeter to eliminate edge loss. So that's simply going to be, and this is a great question. I wish that I'm so glad, Dave, that you asked it, is that you need to do whatever your local code says you need to do. So that's kind of like why it was left off of this slide, because that's purely a local install question that probably your concrete guy will be able to answer for you,
right?
Or your concrete installer. So thank you, Dave. That's a great question. So let's talk about the base layers. What's going on underneath here?
So yeah, here we will kind of slowly start to walk everybody through these layers that we showed all together in the cross section. But the base layer, we really just want to start with a crushed rock aggregate base that is 8 to 12 inches thick or height, and it's tamped down. So it's prepared for that next pour of concrete. And this is actually the slide where we talk a little bit, but just like Scott said, that 2-inch polystyrene insulation may be required by the local code, or some other types of insulations may need to be used here. Yeah,
so check with your concrete installer. They can tell you what your local code requires when it comes to that insulation.
And I just see Dave responded that he's in Alaska, so have a feeling that's a good idea to have some insulation there.
Well, it's probably warmer in Alaska than it is here in Chicago. So thanks, Dave. So, oops, I went the wrong direction. Sorry about that. So here's where the rubber hits the road. This is what needs to be done before you put the cable or the mesh down. So this is what you need to be looking for. Talk about what's in these pictures.
So we have kind of on that lower layer, you can already see that tamped down aggregate base. And that's where you want to set up that rebar or wire mesh nicely suspended for these good 2 to 3 inches, so you can lay your heating product there. That's the whole goal, how you accomplishing having your mat or cable in the middle of that pour. So on the picture on the top, you can see it's just simply suspended, laying on the bricks. At the bottom picture, at the bottom showing like a chairs, metal chairs to hold it, or plastic chairs holding. Pretty much your goal is to suspend it 2 to 3 inches. That way you can install your product, pour your concrete all in once, and the cable will end up being in the middle of that pour.
If you're really cheap, you just go out and get some debris, pieces of wood, rocks, whatever, and use that to prop up the rebar too, like you can see in that top picture. So when you have this and when you're ready to start laying out your cable or your mats, what you want to do is you want to get your plan. We're going to send you a plan, and we're going to be talking about the plan here in just a couple more slides, or probably the next slide actually. And what you want to do is you want to find the location of where the predetermined expansion joints are going to be, because you don't run cables over the expansion or in through the expansion joints. So what we would do in a job like this is we would get this set up like this. We would then do our install plan following the plan that we got, and then we'd find out where the location of that expansion joint is, or where they are. And then what you do is you take that, you make your mark with a can of spray paint, then you mark the edges where once the concrete is poured, it's going to be on both edges on one side or the other where there's going to be paint also. So that guy then, or the person, is going to take their concrete cutter and cut from that marking on one wall over to the marking on the other wall. That's why you have to leave some space between the heating product. And that's where that 6-inch spacing comes from, because that allows you to make your saw cut without going through the cables. And then that'll keep you from damaging the cable. The thing is, if you don't make the mark with the spray paints on the wall or on some surface that's above, once you pour it, you can't
have any reference.
Then you don't have any reference. So you can spray paint the rebar all day long, but if you don't make a mark on the walls on either side, you're not going to know where that went once you cover it up. So that's a word to the wise. Don't ask me how I know that. So let's take a look at the SmartPlan for a cable installation in a bathroom in a house that's a brand new construction, brand new slab. So what's going on here? First of all, what is a SmartPlan and what's on this thing?
So SmartPlan eventually is what we also, of course, call it an installation plan. shows you the layout of the product. Because our goal is, of course, to provide you the best product, the right size product, so it fits and covers the exact area that you need to cover here. So the way we work with that, we of course just want to get a basic floor plan or sketch of the area you are covering. We're going to come back to you with that installation plan that of course shows you the shows you the layout of the plan and shows you lots of additional information more towards the bottom of the plan. The information that electrician can use, because we specified how many breakers and what type of breakers needs to be used, what product it is, what voltage of the product that is, all the additional details like the total amperage and total wattage of the product. So, and also the part I like is operating cost. Like for example, for this particular system, the operating cost is just 6 cents an hour to run that system. So all that information is right here.
Yeah, it seems like a bunch of mumbo jumbo, but it really isn't. These plans are free. There's no reason not to get one. You usually have them within 24 hours too. So don't go in blind. Let us figure out what size cable you need and let us tell you how to lay it out, because our engineers do that all the time instead of you trying to figure it out.
And I think a good idea to point here is that that cable is not any sort of cut to length sort of product. You cannot just pick a larger cable length, lay down, and cut the end or anything like that. So that's why it's a big thing to make sure you size the product correctly, you lay that product correctly, so you ended up right where we show that red circle. That's that end cap that we were talking about a little bit in the previous slides. We want to make sure that we start where the red circle is. That's your start point. You lay that cable according to the layout. And if you end right where that red circle is, which you should end if you just follow the plan right, that's the whole goal. We don't want you to end it up with any extra cable or run short.
Yeah, so when you're talking to your concrete installer, you're going to let them know that there are two areas that are hopefully going to be marked with one of those little metal flags, little construction orange flags with a long metal stick. You're going to stick one right here, and you're going to stick one right here. And you're going to let them know that that's where the splices are. That's where you don't want the installer to be walking. So that's why what you can do is you leave those flags in. They're so incredibly small that they're not going to show anything. And what you can do is once the people are done, because they're going to be walking around as they're pouring this, we know that, but you want to keep them from walking on those splices. And then once they have it poured and they've now stepped off it, they're going to begin to finish this floor. Well, when they start to finish the floor, once the guy's done over by the doorway, he can go ahead and pick this one out. He takes this flag out. He then works his way over here. And once he gets over here, he's going to knock into the flag a couple times. That's going to tell him, oh yeah, I can't stand here. So he's going to finish pouring, then he's going to pull this, and then he's going to start finishing the floor. That's the idea, is put a flag there so they can't physically put their feet in that spot. So that's the start. That's what the triangle means here, start. And that's what the square over here means, the end. So now this one was cable. This one is going to be mats. What's going on here?
So mats, as you can see, it looks maybe a little bit more complicated, but it's really should be faster to install here, because in this particular, again, looks like a bathroom. In this bathroom, we are covering that whole area with just 2 slab heating mats. So one mat that starts right on that top left corner with where this, again, triangle is and the green circle is. That's where we start the mat. We turn it, cut and turn it. Again, that's our kind of initial part of the whole system here, is you just cutting the mesh without cutting the wire and turning and positioning those panels, the sections of the mats, in other words, positioning them according to that legend that we always like to show, just to give you that general idea that you cutting the mesh, turning, making your U-turn without cutting the wire. So pretty much you're positioning these panels and going all the way towards the end, toward that toilet area, and that's where your square is. That's eventually where you will end with that mat number 1. And then for this particular layout, you just need that one extra smaller mat that starts.
Yeah, why didn't they just put this mat over here instead of doing this wacky cut and turn thing and then doing this and that? Why didn't they just start this mat where this one ended up?
So it looks like in this particular example, installer or electrician specified that the thermostat going to be on that wall on the left side. So our products would have a 20-foot cold lead, and we don't want to start doing any extension or connections. We start the mats, our designers, as long as they know that the thermostat connection is thermostat location is right there, they will start the mats as close as possible to that spot. So what electrician will just need to do is just run these wires. If it's just 2 mats, connect them straight to the thermostat and you're ready to go without any extension, without any extra wiring or work.
Yep. So keep that in mind. That's why it's designed this way, to get these cold leads right over to the thermostat instead of having the other one start way over here and go, oops, I'm out of cable. I can't get to the thermostat. So that's kind of the difference there. And that's why they are drawn this way, is to make your job easier. So let's talk about testing. This meter looks like it's incredibly expensive.
And it's actually probably less than $10, if not less than that. Yeah, so the meter that you need to start with is really just a digital multimeter that every electrician should have, and just an additional device that will be needed throughout few parts of installation would be a mega ohm meter. These devices are just to understand if the product is not damaged, if the product is in a good working order. What we want to do with these tools is we want to test the product, the slab heating mat or cable, when it arrives, just to ensure it arrives safely. There's no damaging in transit or anything like that. And then, of course, do the periodical test throughout your installation. So just like we show here, after the product is secured to the mesh, after the final layer is poured. Again, I usually like to say test it before and after every sort of major step of your installation. And in between these time, the circuit check device that is right on the lower right corner of the screen, this is just an alarm, the audible alarm that will create a noise when there is some damage.
When someone takes a rake and pulls up on that
yeah.
cable, beep, it'll do that, because that'll tell you you've got some damage going on. So yeah, that's one thing we didn't show. We don't have a picture of a mega ohm meter. The mega ohm meter is a pretty expensive item. It's a couple $100, but your electrician should have one. A lot of electricians do have one. And it's also called an insulation tester. So the thing is, this is a different installation than, say, putting it under tile or putting it under carpet. Because if something ever goes wrong, you can just lift the carpet and replace the product if you want to. We're talking about installing something permanently into a concrete slab. So the last thing you want to do is have something wrong with this cable before it goes in or get it damaged, because then you're talking about a big job. We can find the bad spot. We can fix it. However, when it's in a concrete slab, it's a much bigger deal. So the mega ohm meter is going to be used in these type of projects like slab heating indoors and snow melting outdoors. Those are the two jobs where you actually need to go get a mega ohm meter and do the test with it, because the last thing you want to do is run into a problem in a concrete slab. So let's talk about the sensor, because we definitely want to get a sensor in the slab, because the slab is generating heat. We want to be able to control it, right? So what's going on here?
Yeah, I like how you pointed that out. We really want to control that system. We don't want to just flip the switch and let it run for 24 hours a day. We want to control it, make it efficient, and run it when you want it and at the temperatures you want it. So that floor sensor wire and the floor sensor probe that eventually all in one piece, it needs to be installed at the same layer, at the same depth where you are installing your slab heating system, because it's just one sensor, but we want to detect that nice average temperature of the floor or of that particular slab. We don't want to have the sensor on the very top, on the very bottom of the slab, or too close to the heating wire. We want to get the nice average temperature, and the best way to get it done is to have a capped 3/4 inch metal conduit. So your conduit is accessible. You slide the sensor in during the installation or so, and this way you also have the ability to replace the sensor if you will need that for at any point or so, because your conduit is open. You slide the old one out, slide the new one in. Everything is ready to go.
Yeah, that's why it's so important to put a capped end at the end of the at the end of the conduit, because if you don't, the concrete just flows into that and then your sensor is stuck. So you'd be surprised how many hot water systems don't even measure your actual slab sensor. They just make their controls based on BTUs and the amount of time it runs and that sort of thing. So you never really know, in some cases, what your actual slab temperature is when you're using hot water. But with electric heat like this, you're always consistently controlling that temperature within 1 degree of what you want it to be. So let's talk about the final layer. We've done all this work, all this stuff is done, and now at this point, what are we left with?
It's
Looks like a fan, a great big fan.
Yeah, it's like we already talked about all these steps, but this is really that final layer where the concrete track comes in, and depending how you set up your installation, hopefully you just did it the way we recommended, in the very easy way where you just suspend that rebar with the bricks. So your heating cable or heating mat at the right depth, and then you just pour in that final 4 to 6 inches pour of concrete. Your cable ended up being in the middle of it. All we really want to have here is just that the cable sits 2 to 3 inches beneath that finished surface.
Yep. And where your flags were, where the people were not supposed to be walking, at this point, the guy, before he starts to get this finishing machine out, he can go and pick those up and or do whatever and get those out of the slab and then start to finish. Because at that point, you have a beautiful finished slab. And let's talk about how do we control that temperature. We do it with thermostats, right?
I almost wanted to say we control this beautifully finished slab with a beautiful thermostat.
Yeah.
But yeah, like we show already the sensors, that sensor gets connected to the thermostat. So the thermostat knows what's the temperature of the floor is. And then you just set it up and control it and test it the way you want. It's very easy to use thermostat. If it's just a normal sized room, you probably will end up as just one thermostat and the whole system. If it's some larger areas or combined zones or areas, you may just need an additional module to it. But it's very easy to use. You set up the temperature you want, and the system just maintains that temperature by turning the system on and off. So just cycling.
Yeah. We had a question from from Laura about how much height will this solution add from the top of the slab to the bottom of the finished floor? 0, because it's actually included inside the slab. So if you take a picture like slide number 9 or slide number 10 where we showed the layers, it's in there. So it didn't really add any height. So if you wanted a 4 or 6 inch slab, that's what you're going to end up with, because you're going to put the cable right in the middle of that slab. So it doesn't add any height. It's when you get into heating on top of a pre-existing slab, that's where you're going to add maybe an inch and a half, because you're going to put Cerazorb over the top. You're then going to put the wire and then the final flooring. So that's a great question, Laura. And Chris asked if this could be used for commercial use. A lot of places we get calls from warehouses, people that want to heat the part of the warehouse where the people stand, as opposed to out where the trucks are going back and forth, that sort of thing. And this is it. If your slab can take it, soak in the heat. The thing is to keep in mind is if your slab is inferior, if it gets too thin, if it starts to break up and crack, if a slab starts to do things like this, crack and then separate, when it does that, it can shear the wire. So right. If your slab is not strong and it fails, there's a chance if it does a shear that it could cut through the cables. But that's the one thing you very, very rarely see that. It's usually not an issue. And when it is, it's when the guy said, "Oh yeah, I poured you a 4.5 inch slab and it was really 2." So that's the kind of stuff you have to watch out for. We had another question, but I'm going to go and answer that a little bit later. But here, I love this slide because it shows a finished concrete slab, right? And it also shows some of the stuff we've been talking about.
Yeah, I love that slide as well. I mean, you never know with these days with the new technologies how nicely you can get that slab polished or stamped. I mean, there are just some amazing finishes that we saw. So again, this really, that type of surface picks up. I mean, it really can add a nice look to that interior design. So again, the concrete installer or designers later on can really just finish and polish that slab to the best stability, to the best design that needs to be matched here.
And what I like about this is it shows the expansion joint.
Sure.
Right here. Some decorative joints here, but there's an expansion joint, which means this area is heated as its own monolithic slab, and this area is heated as its own monolithic slab. You don't run the cables back and forth like this. So it's got one, really they're 2 separate slabs, one here and one here. If you, excuse me, if you were to use the felt separator, but they didn't here, they just did cuts. But that's where you have this and allows the slabs to move independently. And if the slabs move independently, there is no cable going between them. So you don't have to worry about that shear. Also, we are never going to heat under anything permanent. So if this were a permanent cabinet, the heating coils would be here, but not underneath.
Right.
That's the one thing you want to keep in mind is if you have permanent fixtures in the room, you do not heat under permanent fixtures like bathtubs or toilets or that sort of stuff, or a cabinet. If you know you're putting a cabinet in the bathroom, you need to draw that space for us so we don't put heat under there in the drawing. Then all of a sudden you get the roll from us and you go, oh, I forgot to tell them about this cabinet. Now I have too much cable because I took, whenever you add a feature like a permanent cabinet, you're then subtracting from the available square footage of the room. If you subtract available square footage, you're taking away the possible area for the cable to go into. So you can't just shrink the room and then use the same size cable. Can't do that because you can never ever cut or change the length of the cable. So if you have any questions, go ahead and type away. We did have a question from Lon, and he asked, are there any restrictions or issues for installing this into lightweight concrete over an unfinished basement? Well, you have to remember, Lon, that if it's an unfinished basement, it may be unheated or an unconditioned space. Whenever you have an unconditioned space below a floor, you have to worry about not only the heat going up, but you have to worry about the heat being lost from underneath. So that's the case where if you have an unheated area below, you may not want to heat the slab. You may want to put Cerazorb over the top of the slab and then put our temp zone product on top of that, because that'll isolate the cable from the cold slab, because that slab is not only going to be its normal chilliness, but now you've got 30 or 40 or 20 degree air below it, trying to make it colder. So what you want to do is you want to isolate the heat from the cold. So you either insulate underneath the slab and put it into the slab, the heat, or if your slab's already there, you put a layer of insulation over the top of the slab and then put the cables on top of that. So hopefully that answers your question, Lon. Thank you for sending those in. And if you've watched a few of our webinars, you know that we always ask you for more questions and that sort of stuff that you can send us ahead of time so we can make sure we answer them for you. So I'd like to thank Gary. I'd like to thank George, Laura, Chris, and Lon for sending in your questions.
And Dave had a good question.
And Dave
as
had
well.
a great, yeah. Thank you,
all the
Dave.
way from Alaska.
So let's talk about our next webinar, since I don't think we have any other questions submitted to us. And our next webinar is going to be on Thursday, May 9th at 1 p.m. Central Time. And that is Get the Spa Bathroom Experience with Radiant Heating. That's going to be very luxurious. So make sure you stick around for that. And our April promotion is 25% off of Metropolitan towel warmers. So if you are in the market for a towel warmer, now would be a really good time to get one. Since they're 25% off, you can visit WarmlyYours.com and get a hold of us. And we also value your feedback. Please let us know what you thought of this webinar, if it was any good, if it was bad, what could be improved. You know, I wish this guy would have combed his hair better before, or whatever. Anything like that is fine. But make sure you let us know what you thought of this. And if you have any ideas for new material, feel free to do that, because, hey, if you're interested in it, why don't we talk about it, right?
Sure.
So we appreciate your comments and suggestions. And that's all I'm going to do to beg you for your information. So please contact us whenever you want to at 800-875-5285. Our emails are there on the slide, and our web presence is there at the bottom. So that's where we are. That's who we are. And feel free to get a hold of us anytime. Until the next time, stay warm
And be radiant.
So long, everybody.
Bye.
Thanks.